students, welcome to my channel, and today we are taking our next level of classes, going ahead of the previous class, that is degree of indeterminacy. What we have studied today, we'll deal with some important and basic examples, numericals, that how to find out the degree of indeterminacy. So let's get started. So first of all, we'll deal with degree of indeterminacy of beams. After that, we'll deal with rigidly jointed frames, and in the next video, we'll deal with pin jointed frames. So today we are going to deal with only beams and rigid jointly frames. Rigid jointly frames are further divided into plane frames and plane frames and space frames. In plane frames, we'll deal with single storied frames, and in the second we'll deal with multi-storied frames. Before we start this topic, as we have previously studied, a revision of the support reactions of concerned supports. For example, as we have discussed that roller support having only one reaction, second hinged support is having two reactions, and the fixed support is having three reactions. Again, we'll see that here, if any internal hinge is provided in our structure, then we have to consider the same as one additional equilibrium equation. That means if a internal hinge will be given, if in question one internal hinge is given, then as we know that we have three equilibrium equation, then that particular hinge will be added to the equilibrium equation, then total will have four equilibrium equations. Means the additional hinge what is given should be considered as an equilibrium equation. And one more thing, we should consider that the moment at this hinge should be equal to 0. That means only we have to consider the equilibrium equation and consider the moment of the hinge to be 0. So this is the basic concept we should know before we find the degree of indeterminacy. Now let's start solving the basic numericals related with beam, or questions with beam, in which we have to find out the degree of indeterminacy. So let a beam like this has been given to you, and the question is to find out the degree of indeterminacy in this particular structure. Then as we know that in fixed support we'll have three unknown equations or reactions, in fixed end we'll have three unknown reactions, whereas in the other end where it is a hinge support we'll have two reactions. That means total will have five unknown reactions. As we know that the degree of indeterminacy we find, let I am taking or naming it as n, that the degree of indeterminacy is equals to number of unknown reactions minus number of equilibrium equations. As we have previously discussed this equation in the previous classes. So applying the same formula here. So here we have in this left hand or fixed hand we have three unknown equations and here two unknown reactions. In the left hand where a fixed support is given we have three unknown reactions, and in this right hand where a hinge support is given we have two unknown reactions. So the number of or degree of indeterminacy here will be 3 plus 2, and we know that total we have three equilibrium equations, that is summation of fx is equals to 0, summation of fy is equals to 0, and summation of all moments are equals to 0. So here we'll get 3 plus 2 that is 5 minus 3 that is 2. So for this structure the degree of indeterminacy is 2. Again in the second question it is given where both the ends are fixed for a given beam. In such case we know that the fixed end will give us three unknown reactions and both will give three unknown reactions. In such case we can see that here in this end there are three unknowns and in this end there are three unknowns, that is total will have six unknowns and we have three equilibrium equations, which will be 3 minus 6 that is 3. So here the degree of indeterminacy is 3. Again we take few more examples, such as if a beam is given and having a hinge support at one end, one more support is given in the center, that is roller support, and in the end again a roller support is given. So we know that for hinge support there are two external reactions, for roller support having one reactions in both the supports. So here we'll have two unknown reactions, here one unknown reaction, and here again one known reaction. So our degree of indeterminacy will be total 2 plus 1 minus 3, that is 4 minus 3. So the beam will have a degree of indeterminacy of 1. Again now if a beam is given in which two internal hinges are given with a center having a support of a roller and ends are supported with a fixed end. So we know that the fixed end will give me three unknown reactions and the roller support will give me one reaction. One thing important here what we have to consider is that this internal hinges should be considered in the equilibrium equations. That means we will have two extra equilibrium equations, or we can say that the number of reactions will now be 3 plus 2. So here if I consider number of unknown reaction at this support is 3, at this support it is 1, and here it is again 3. So my equation to find out determinacy will be 3 plus 1 plus 3 as the number of unknown reaction at these supports, and the equilibrium equation I know is number of equilibrium equation is 3 and I have to add here 2. This is for the two internal hinges given. So my equation will now be 7 minus 5, that will be equal to 2. So this, for this particular type of beam, my number of or degree of indeterminacy will be 2. So this question is much important than the previous 3, as here it is a special case of internal hinges. After completion of the beams for degree of indeterminacy, now we'll solve for rigid jointed frames. That is, first we'll consider for plane frame. So in the plane frames, okay, again to consider 2 points arises, that is for single story frames and double or multi-storied frames. So here for single story frames, the solution of degree of indeterminacy will be same as that of beams, as we have solved till now, and little changes will consider in the double or multi-storied frames. Here single story frames that are same to that of beams means the reactions and independent static equilibrium equations have same values as that of beams. So let us see few examples for single storied frames. If a question is given, that is a single story frame having a fixed end at one end and fixed end support at one end, and the other end has a rolling end. So here, as we know that in beams I'll have 3 unknown reactions at the support and 1 unknown reaction at the roller support. Hence my degree of indeterminacy, what I am denoting it by n, will be 3 plus 1 minus 3 equilibrium equations, that is 4 minus 3, which will be equal to 1. So this is as simple as that of the beam. No further considerations have to be considered. Again, if I consider a similar type of frame of one story in which I have 2 ends supported with hinges, then as discussed, I'll have two ends of hinge support, then I'll have 2 unknown reactions at the hinge end, that is at the both in hinge ends. Then my degree of indeterminacy in such condition will be sum of 2 plus 2, that is unknown reactions, minus equilibrium equations, that will be equal to 1. 4 minus 3, 1. Further, if I take some more examples, then if my both ends are supported with one fixed and other hinged, then as discussed, I'll have 3 unknown reactions at the fixed end and 2 unknown reaction at the other end. Then my degree of indeterminacy will be 3 plus 2 minus 3, that will be equal to 2. Now if one last example I'll take, that is if a frame is like this, and one more member is also given at the center, then in this case, as I know that there are three supports of fixed, that is each will give me three unknown reactions, then in such case my degree of indeterminacy will be sum of all three fixed end supports minus my equilibrium equations. So here this will be 3 minus 6, that is equal to 6. For such frames the degree of indeterminacy will be 6. Today we'll end up our class here, and in the next class we'll study space frame numericals and pin jointed frame numericals. If you really like this video and you want to motivate me, then kindly subscribe my channel, and thank you for today.